the form of the solid once we've rotated it about the x-axis. I'm going to show you 4 functions just building on top of each other. Just quickly, and I'm going to show you 2 different versions. So here's the line y equals 2, and if I rotate that about the x-axis, this is what happens. Okay, it rotates around this way. So what you get is the sense, hopefully, that this is a circle on the end of radius, what is it, 2, right around. Now if I flick over to my other screen, here is what the cylinder looks like when y equals 2. Okay, there's our x-axis. Now this is on a just offset a little bit so you can actually see the circle and get a good idea of the cylinder in this example. Okay, so we go back to the other one, and not that one. And we're going to now just put a negative 3x. I'm going to stop and reset that. And let's have a look at this one. Okay, so there's the line. You've got a bit above, bit on the left-hand side over here. So when we revolve that, what we're going to get is, well, this is going to be I suppose a cone shape, and this is going to be a cone shape as well. So we're going to get a funnel or a cone on this side and this side, and you pretty quickly get an idea about what these things are going to look like. Again, it's always this circular end at both ends. And just having a look at the other one then, if I put negative 3x there, that gives you an idea that we've got quite a wide base on the negative side, so this side here. Okay, and there's my smaller side, which is the rotation of this. Okay, so I'm just going through showing you how these different things look. I'm going to put a negative x squared there, and okay, so resets. So we're working with a parabola, and again the question is going to be something like, now normally the question will be just find the solid formed by the point, say negative 2, and this point here, which is 1, 1/2 I think it is, rather than having these 2 ends, 2 different solids. But you can see the idea that you can work it both ways. Just you always need to be conscious of where the root of the equation is. Let's have a look at that over here. So we just put negative x squared on it. Okay, now you see how we got this curved shape now. So this is where the curve is, and hopefully what you get the idea is it's starting to come back in. So this is coming back from a maximum point. So there's our maximum turning point in terms of the solid, and it's now beginning to fall into, well, back down towards that other root, that's 0. And if I extended this out a bit, then that whole solid here would get enclosed, and then be another funnel over here as it starts going at a cubic and a quartic. So I'm going to put 2x to the power 3, and again it's just to see how all these things change. Okay, let's just move this up a bit so you can see it. Well, some of it, you won't see all of it on this one. Okay, so once again we have a curved section here. So it's not a cone, it's not a conical shape, because it's a curved area, not a curved edge I should say, not a straight edge. And you see a second solid being formed in here, and it looks like just a very small solid formed there as well. Let's have a look at the other one. We had 2x cubed. Okay, a bit more difficult to see this one. This very wide part of the diagram here is this, as it falls very quickly. More difficult to see, but you can see there's the small end just over here. There is a very small, there's a turning point just below the x-axis at this point here, which is that little bump there. Here's this enclosed section I tried to describe just a minute ago, which is this enclosed area here being rotated, and then this very wide section being rotated about the x-axis. Okay, last one. And I'm just going to throw in an x to the power 4. Stop. And so there's our shape now. This time there's no intersecting points on the x-axis. Okay, so what we get is this shape. Okay, once again, we've got a circle here. We could find out its radius if we found the point of intersection at -2. So we substitute -2 into this, and that gives me that height, which will be approximately 4, might be 4. And then we can, if we wanted to, for some reason, find the area that's cross-section there. But obviously the cross-section, as we move through this thing, changes. And this diagram will show that a bit better. So x to the power of 4. Okay, and there we have as the shape dips towards the x-axis, we have a narrower part of the solid, and then out wide, coming back in, which is that bit coming back in and then coming back out. And just to show you one more, I don't think we want to move x. Yeah, what you can see is this is moving the cross section right through the shape, and you should be able to see that the size or the height of this line here dictates the size of the cross section. Okay, so when we get down here, we've got just a narrow shape. And just by way of observation, just by interest, I suppose, have a look at this. Not like that. If I just try and pull this back. We make the rotation about 180 degrees, which is now not enough, but you get an idea that while you're ever asked to rotate only 180 degrees, you get an idea of how the shape is developing, the solid is developing as we move towards 360 degrees. Okay, so there you go, that's all you need to know, but it's worth having a look at this thing and seeing what sort of shape is formed with respect to the questions you'll get asked on an HSC. Thank you.